Well, welcome. Today is Thursday, January the 28th. You're at AL Chemistry here at Spain Park High School. And once again, if you're enjoying these videos, please feel free to subscribe to my channel. All right, so today what we want to do is go over the study guide and get ready for the test that's going to be occurring tomorrow. Okay, so everybody, if you're watching this video, you need to be ready during class time to take the test. If you're taking it at home, you will have 10 extra minutes and just give you time to download and upload. Okay, but it needs to be finished within that time frame. So this is not a do at your own. It's also open book, open note, but it is not open internet or open anybody else. Okay, so I actually put on the answer sheet for just the honor code statement on that. Okay, I just want to kind of get what is, how much do you know, are you getting it? Really make this a comprehension survey. So let's just kind of go through this quickly, and I would love for you guys to feel free to answer and respond back. But what happens to electrons in ionic bonding?
They're transferred.
They are transferred. So what gets formed?
Cation and anion.
A cation and an anion. You form ions. So metals, what do they do with electrons? Gain or lose?
Lose.
Lose, okay. Non-metals then obviously
Gain.
gain. So if a metal loses an electron, what charge does it form? Positive, okay. What charge does the non-metal form?
Negative.
Okay. Now Sam's answering, but are you guys getting that? Okay, we understand metals lose, make positive, non-metals gain, which make negative. So what holds them together?
Because they're opposite and they're pulling towards each other.
Okay, the opposites attract. Okay, so positive attracts negative, and that's the actual bond. We call it an electrostatic attraction. An electrostatic attraction. So, we just said the type of elements form ionic is going to be a metal and a non-metal. In the formation of an ionic compound, which type of element gets oxidized and which gets reduced? What does oxidized mean?
Loses an electron.
Remember Leo goes Gur? Okay, we talked about this when we were dealing with electrons. What does Leo goes Gur mean?
Lose an electron from oxidation.
Is oxidation,
gaining electrons is reduction.
gaining electrons is reduction. Okay, so loss of electrons, oxidation. It's hard to write down. Gain of electrons, is reduction. Okay, so we just said it. Which one's losing? Who's getting oxidized, metal or non-metal? Metal's getting oxidized, non-metal's getting reduced. So that's just putting the oxidation to what we just said. All right, ionic compounds are composed of what type of ions? And this is a real tricky question. Ionic compounds are composed of what type of particles? Okay, did you hear what he said?
No.
What did you put? Ions, good answer. Okay, it's real deep. Ionic compounds are composed of ions. That's the name ionic compound. Okay, so 5 properties. Now, not only do you need to list these 5 properties, you need to know the whys. Okay, so what do we know about the melting and boiling points of ionic compounds?
High melting.
High, okay? We have strong electrostatic, strong coulombic attractions between the positive and the negative. So it takes a lot of energy to break them apart. So they have high melting boiling points. So what state are they going to be in at room temperature?
Solid.
Solids. Okay? Now, do they conduct electricity in the solid state?
No.
No. Okay? Why not?
Because the ions are trapped in between each other and they can't move around.
They can't move. Remember, this is an answer to one of the ones. What is electricity? Define electricity. Remember, electricity is the flow of charged particles, right? Electricity, what number is that one? That is number 10. What is electricity? It's the flow of charged particles. So we have charged particles. We just said that an ionic compound is composed of ions, cations and anions, positive and negative. So we have ions, but they just can't, what? Flow. Because they're held rigidly in place in that solid, in that crystal lattice structure. Okay? So how do we give them mobility? How do we let them flow? What do we do?
Dissolve in water.
Dissolve them in water, because the water breaks them apart into individual ions, or melted. Because that again breaks the ions apart and gives them mobility so they can roll around one another. So they don't conduct in the solid state, but they do conduct in the aqueous and molten state. What do we call a solution that conducts electricity? A substance that when dissolved in water conducts electricity.
Electrolyte.
Okay? Did you hear what he said? An electrolyte. Okay, and we think of Gatorade. We talked a lot about that. So electrolytes are one of the main types of electrolytes are ionic compounds. Okay? At the end of the year, we'll talk about acids and bases, and we'll find that those are electrolytes too. They dissolve as ions. But the most common ones, and the ones that Gatorade always talks about, are these ionic compounds. Okay? So, that's a big thing. You need to know why or why not that ionic compounds don't conduct in the solid state. The ions can't flow. There's charged particles, but they're locked in a rigid crystal lattice structure, so they can't flow. But you put them into water or you melt them, you give them mobility that allows them to conduct. All right? What's another characteristic? Brittle. Why? Brittle means they're going to shatter into smaller pieces when hit. What happens when you hit an ionic compound? Why does it break apart?
Because
You're breaking the bonds apart.
You are breaking the bonds, but
it's putting the positive on positive, and
when you move it, you make positive get next to positive and negative get next to negative. Instead of retracting, they repel and push apart. Okay? So it's just a little twist. And I'm gonna pass this around now. Y'all be careful. As you twist too hard, they're gonna all go flying. But just twist it and kind of feel how we go from attraction to repulsion. Okay, try and put the, if you put, even just if you need to, pull 2 green ones off and just try and put them, put the 2 green ones. You should feel the repulsion. Well, they're still going to be magnets, so make sure you put the same charge, the same size, and feel the repulsion. Okay, so they're brittle because when you hit them, you change the structure. You force positive next to positive, negative next to negative, and they're, instead of attracting, they repel. And so that caused them to shatter into smaller pieces. Okay? Now, what's another product? I told you. It's over here, I got it. All right, so obviously you weren't the first person that ever happened to, because I warned you about it. We have an issue. Did it stop?
no, it says low battery spot on the screen.
Oh,
I got it. I fixed it.
okay. Pause, and I try to make good videos, but there's always something. Olivia, is that plugged into the wall over there?
Yes.
Sorry, y'all, little technical difficulties here. I probably cannot stop right now, because I forgot to put on Do Not Disturb, so as soon as somebody texts me or whatever, it's gonna go off. So we'll start it over again if that happens, okay? All right, so one of the other properties, and this is an important property, is that ionic compounds are soluble in water. Many are soluble in water. Why is that?
They're polar. And water's polar. so-
Water's polar. Ionic compounds are not polar or non-polar. But ionic compounds are composed of positive and negative. So you put it into water, the oxygen is going to be attracted to the Na plus. The hydrogen is going to be attracted to the Cl minus, and it pulls it into solution. Okay? Because there's that strong attraction between the water and the ions. And as a result, they're very soluble. So waters completely surround this thing, okay? And it takes more than just one, but you put the waters all on here, and then it slowly will surround this and have enough to pull it apart. So you can see the salt grain, you know, in the salt shaker at your house, but when you put it into water, it breaks up from having billions and billions and billions and billions and billions of these all together into individual ions in the water, so it disappears, we can't see it. It's still there, it's just completely separated. So, ionic compounds are soluble in water because of the strong attraction, and I gave you that sheet, and we would call that an ion to dipole attraction. The ionic compound is the ion, the Na plus and the Cl minus. Water's the dipole, the polar molecule. So it's an ion to dipole attraction. Okay? Feel free to write some of that down, like in the margins and things as you go. All right, so is there any other property of ionic compounds that I didn't hit? The two biggies.
Crystallized solids.
Do what? Oh yeah, they don't form molecules, but instead form large crystal structures, okay? So there's no NaCl. It's gonna be just this, you know, Na plus surrounded by Cl minus surrounded by Na plus. So unlike water, which is a very unique, just, you know, it's just, you know, it's one thing. It's H2O. It's a small molecule. There's an individual unit, discrete unit. You don't have that in ionic compounds.
The
All right.
coordination number gives number of ions of opposite charge that surround each ion.
Yeah, but you don't have to know anything about coordination number. Okay, so if you put that down, you can put a line through it and know that you don't need to know that. Okay? So we already talked about why are ionic compounds brittle, so you need to have that written out. That is a potential short answer question. Okay? Why can't ionic solids conduct an electricity in the solid state? What did we say?
Because the ions cannot move.
That's right, the ions cannot move in the solid state. They're held rigidly in place in a crystal lattice structure, if you want to be fancy. Okay, so then when can ionic solids conduct electricity? When you melt them or put them in water, because that gives them mobility, so now the ions can flow. So you need to just put the part, don't just say when they're dissolved in water or melted, because that gives them, gives the ions mobility, the ability to move. Okay, so we already defined electricity, number 10. Metallic bonding. What's the key phrase in metallic bonding? A metal, what, surrounded by?
Sea of free floating
A
electrons.
sea of free-floating valence electrons. That's going to be your answer for everything metallic. A sea of free-floating valence electrons. So why do they conduct electricity in the solid state and liquid state?
Because the electrons can flow free.
The electrons, charged particles, can flow. They can flow freely even in the solid state. Liquid state too. Now we don't normally think of metals as a liquid, but mercury is a metal and it is a liquid at room temperature, and it's got some unique characteristics, and they can use that, the fluidity of the mercury, to help do different things. And I showed you that thermostat a long time ago. Okay, what's an alloy?
A mixture of two or more metals.
A mixture of two more metals. Give me some examples of what you think an alloy is.
A wheel.
Aluminum alloy wheel. Okay, this means it's aluminum mixed with other stuff. I'm not quite sure what it is. Okay, probably based upon the color and the texture, you know, they mix it with different things. What else? Some alloys.
Is it like the metal on like the fenders like on a car? Isn't that like alloy? It's like a mixture.
It could be. Simpler than that. What do you have on your finger there, Olivia?
A ring,
Okay, is it made out of gold?
fake, it's not like real gold.
Okay, but if it were gold, what would it be? What kind of gold do we call it?
Like a carat, different.
Which carat is normal gold?
24.
Well, that's pure gold. It's 24 karat.
14.
14 karat gold is what most jewelry, especially on the earrings, you gotta make sure you have good earrings, otherwise your ear will get infected. You know, if you have good jewelry, you know, it won't turn, but if you have the alloy made out of copper, whether it's bronze or brass, it'll turn your fingers green, you know, eventually it just kind of starts corroding. Okay, gold is great because it doesn't corrode, but if you have 24 karat gold, it's super soft, it's malleable. So it would bend, it would lose its shape. So they add silver and some copper to it to kind of give it some strength so it can keep its shape. Yet it still maintains the point where it doesn't react and all of those things. So an alloy is a mixture, it's not a chemical. Metal does not chemically bond with another metal. Gold only bonds with gold, silver only bonds with silver, copper only bonds with copper. So metals are the most simple crystals because it's only one type of atom. All right, why can metals conduct electricity in a solid state? Because they have the sea of free-floating valence electrons. Why are metals malleable? When you hit a metal, why doesn't it break apart like an ionic substance does?
Because the electrons just move to another spot.
The electrons can move to keep positive from getting next to positive and negative from getting next to negative. Okay? So metals are malleable because the sea of free-moving, free-floating electrons move with the cations, keeping positive from getting next to positive. So again, everything metallic, it's sea of free-floating valence electrons. All right. Electrolyte, non-electrolyte, we kind of already did that. Electrolyte is a substance that conducts electricity. It dissolves as ions, so it'll conduct electricity in water. A non-electrolyte dissolves as neutral molecules. Ionic compounds are electrolytes. Covalent molecular substances are generally non-electrolytes. Ionic substances are electrolytes. Covalent molecular and covalent network don't even dissolve in water, so covalent molecular is the only one. What are the 5 covalent network substances?
Diamonds, graphites.
Okay, go ahead. Yeah.
Diamonds, graphite, sand, silicon, carbon, and silicon.
Okay, silicon carbide, SiC. I think that's the last one you were saying, Miss. So silicon carbide, SiC. Silicon. Silicon dioxide, which is sand or quartz. Diamonds and graphite. Diamonds and graphite are the most common, and again, it's a covalent network, so there's no individual diamond molecule. It's just carbon atom bonded to carbon atom bonded to carbon atom, sp3 hybridization, tetrahedral arrangement around each carbon, giving it a 3-dimensional covalent network, very hard. Whereas graphite, your pencil lead, is AX3 trigonal planar sp2 hybridization, to where it's going to be trigonal planar, so we get flat layers that are weakly bonded to one another by pi bonds between the layers. The non-hybridized p orbitals are perpendicular, and the electrons can all move in between here, but the layers slide over one another. This is the fascinating thing about chemistry. Cheap pencil lead, diamond, a girl's best friend, both made out of pure carbon. The only difference is how the carbons are arranged, their molecular structure. Okay? So the way you know it's covalent network, it's one of those 5. All right. 3 properties of covalent network. We can just go through that. They're very hard, high melting points, so they're going to be solids. They're neutral, so they generally don't conduct electricity.
Brittle.
They're going to be brittle. Okay? So they don't conduct electricity hardly at all. Graphite's an exception, but you don't really need to know that exception. What happens to electrons in covalent bonding?
They're shared unevenly between.
They're shared between 2 atoms. Okay? They could be evenly or unevenly. If it's a non-polar covalent, they're shared evenly. If it's polar covalent, they're shared unevenly. But they're still shared. Unlike ionic, that's completely transferred. Okay, what type of elements combine with covalent molecular are gonna be what type of elements?
No.
Two nonmetals. Okay? And then covalent molecular substances are composed of what type of element? We just did that one. 20. What is the attractive force holding atoms together in molecules? So in water,
Pi bond?
no. We look here, and I'm gonna put an X for this one, and an X that one. The bond is these electrons being drawn to that nucleus and to this nucleus. So it's the electron being trapped between the two nuclei, being equally pulled or being pulled towards each nucleus, and that kind of holds everything together. So it's the sharing of the electrons as each is attracted to the other nucleus. Nonpolar covalent. What's the only type of IMF between nonpolar molecules? London dispersion forces, good. Okay, they're the weakest of all. So nonpolar substances tend to be gases or volatile liquids, meaning low melting and boiling points. Okay, they're neutral, they don't dissolve in water. They're nonpolar, and they don't conduct electricity. They will still be brittle. Think of an ice cube, but you hit it, it's gonna be brittle. Although an ice cube would be polar, so the only difference in polar is that they're soluble in water. Everything else is gonna be the same. They're gonna have a little bit stronger attractive forces, but they're still gonna be liquids or gases at room temperature. So what does it mean that water is polar?
It has oxygen, uses the electrons one time.
What does polar mean? What does polar mean?
Uneven sharing of electrons.
Well, an uneven sharing, okay? So what does that cause, what does happen to oxygen then if the electrons are being pulled more this way?
The electron collider is bigger on the oxygen.
So that makes it what charge?
Negative.
Negative, because electrons are negative. But it's not a complete transfer, so we use this delta symbol to represent partial negative. And each hydrogen is going to be positive because the electrons are being pulled away from it. So this is partial negative, partial positive. It's polar. It's got positive and negative ends. That's what polar means. It's got positive and negative ends. Why does styrofoam cup dissolve in acetone?
Light dissolves light.
Light dissolves light, right? Okay, so we saw that demo in class. You guys were here. So styrofoam is nonpolar, acetone is nonpolar, so they dissolve. But why doesn't that styrofoam dissolve in the water? In the water?
Water's considered polar.
Water's polar. So there's very little attraction between the polar water and the styrofoam, and as a result, the water molecules don't want to break apart from one another because they're held together with strong hydrogen bonds. So it just sits there and it makes it a great cup. Like dissolves like. So all of these questions deal with that. How does detergent work to help clean your clothes?
It has a polar and non-polar end, and it
Polar and
connects
non-polar end.
with the water and to the oils, combines them together so they can.
What's the fancy word for that? That links the two non-soluble things together. It's two words.
Emulsifying agents.
Say that again.
Emulsifying.
Emulsifying agent, very good. Okay. Now, they also lower the surface tension. Remember we talked about having the pores in the clothes. It'll lower the surface tension and allow that film to get broken and allow the dirt out. Okay. It lowers the surface tension. Describe how soap works to clean oil off your skin. It's the exact same thing. It's got a long non-polar part. It's got a polar head. The non-polar attracts to the oil. The polar attracts to the water, links the two together, and causes it to go down the drain. Doesn't really make them soluble. It just links them and keeps them from separating. And then dry cleaning uses a non-polar solvent, whereas regular laundry uses polar water. That was all on Monday's discussion. All right, now 27 is a biggie. How can you look at these things just like this and know what they are?
Look for phone call.
You can look that's gonna tell me whether it's polar or not. That's really gonna be more on 28 than it is 27. But I just wanna know if it's ionic, metallic, covalent network, covalent molecular. Ionic compounds are composed of what type of elements? We already said. Metal and a non-metal, whereas covalent is
Double non-metal.
two non-metals. So the second thing is always a non-metal. It's the first thing that's different. If the first thing's a metal, we know it's ionic. If the first thing's a non-metal, we know it's covalent. If it's just one thing like D, AU, that's gold, it's gonna be a metallic bond. But what about C, the letter F, where it says C diamond,
Covalent network.
covalent network? We just memorized the 5 of those, that's how you know. But you go and look at MgSO4A, magnesium's a metal, so therefore that compound's going to be ionic. H2O, and just so you know, hydrogen always acts like a nonmetal when it bonds. It's over there because it has one valence electron, but it always acts like a nonmetal. It's a gas. So it's two nonmetals, so water is going to be covalent. You look at C, the first element is carbon, which is a nonmetal, so we know it's covalent. Gold, we said, was metallic. Calcium carbonate, calcium's over here, number 20. It's a metal, so that type of substance is ionic. Diamond's the word covalent network. SO3, sulfur's a nonmetal, therefore it's covalent. Hg, just by itself, it's going to be metallic. And NaI, sodium's all over here, far left, so it's going to be ionic. Are we all good with that? You must be able to identify ionic and covalent, and it's just that easy. All right, now lastly, this is the most important part. You see on your answer sheet that you're definitely going to have to do these things, okay? So, first thing is CH4. This is an easy one. What are my steps? What's the first thing I need to do to draw the Lewis dot structure?
Find the central atom.
Now, before I find the central atom, what? Add up the electrons. So we go and look, the carbon has 4, hydrogen has 1, but there's 4 of them, so a total is 8 electrons. Got to do that first. Then what do we do, Sam?
Then find the central atom.
How do I know the central atom?
Hydrogen can't be.
Hydrogen can never be, and it's the one you have the least of. Okay? So it's going to be C, and then we just build around it. And each line represents how many electrons? 2. So I have 2, 4, 6, 8. How many electrons does hydrogen need?
2.
Only 2. Everything else needs 8. Hydrogen only needs 2. So that's it. So what's my AX formula on this?
AX4.
AX4. Okay? Then you go and you look on your sheet and you see AX4 is a tetrahedron. Tetrahedral. Okay? And because it's 4, we know it's going to be sp3 hybridization, because 1 plus 3 equals 4. And then the shape, we have the shape. Now, is it symmetrical or asymmetrical?
Symmetrical.
Okay? Again, symmetrical. There are no lone pair on the central atom, and all the bonding atoms are the same. If I just did this, if I did that, now it's going to be asymmetrical and polar. Even if I did this, it still looks symmetrical, but it's not, because it's in 3D, this is 2D. Okay? These, all 4 are not the same, therefore it's still asymmetrical. So don't always trust your drawing as whether it's symmetrical or not. Trust the rules. Okay? So since it's symmetrical, it's automatically polar or nonpolar? Nonpolar. Okay? The next one is SO3.
What about the attraction force?
Oh, the attractive force. Oh, if it's nonpolar, The only attractive forces are gonna be LDFs. That's it. All right, so the next one's SO3. So count electrons. How many electrons do we have?
24.
Okay, how'd you get that, Madison?
I did the 6 on sulfur and then I did 6 times 3.
For 18. So 6 plus 6 times 3 is 18, so we have a total of 24 electrons. Are we all good with how to do that? Okay, so my central atom obviously is going to be sulfur. You always build around it. Don't put the oxygens in a chain. Build around the central atom. That's 2, 4, 6. Put the extra electrons all around the outside first to get 8. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We have a problem. Sulfur doesn't have enough, so what do we do?
Which
You form a double bond, okay? Now, somebody in the other class, you know, when they were doing these, they looked them up on the internet. When you look it up on the internet, sometimes some of them show it like this, okay? There's a thing called formal charge, which is a different method for drawing Lewis dot structures. We didn't cover formal charge, okay? So, even though both of these are considered correct just based upon how you're looking at it, this one's obviously way more complicated. How it bonds, I'm not really quite sure on the overlap of everything. But you're not gonna have to do this, so, you know, don't always trust the internet. You're not supposed to use the internet on the test, but I'm gonna know if you do because some of them use that formal charge and we don't know how to do the formal charge. You need to draw your Lewis dot structures like we know how to do. So what's my AX formula here?
AX3.
AX3, so I go to my sheet and I find that it's trigonal planar. Then since it adds up to 3, my hybridization is sp2, okay? Is it symmetrical or asymmetrical? Symmetrical. Don't worry about the double bonds, just know that no lone pair, all 3 are the same. So it's symmetrical, meaning it's nonpolar. So again, what are the only type of attractive forces? LDFs. So this is a gas at room temperature, this is a gas at room temperature. CH4, by the way, is the gas that comes out of your gas vent right here. So it's just natural gas is CH4, methane. HCN. Make sure you can see this one, Sam. HCN, we count electrons. Since everybody knows how to count electrons, 1 plus 4 plus 5 makes 10 electrons. Now I know that hydrogen can't be my central atom, but I have a tie between carbon and nitrogen. When there's a tie, which one do you use?
The smaller.
The one with the least number of valence electrons. In this case, it's carbon. So I say carbon, nitrogen, hydrogen. Go ahead and if you just have 3, they're going to want to get as far apart from each other as possible. That's just the valence shell electron pair repulsion theory. So I have 10, 2, 4, 6, 8, 10. Carbon is missing out, right? So I share here, but now carbon has 6. I share here, we get 8. So what type of bond is that? What type of bond is that? Single, double, triple. That's a triple bond. Okay, so how many sigma bonds in this molecule? How many sigma bonds are there and how many pi bonds are there? 2 what? 2 sigma. Sigma, sigma. What about pi? Remember the second and third bonds of a double bond are always pi bonds. So this would be pi, that would be pi. So you have 2 sigma and 2 pi. All right, this next one, D. Oh, well, let's just talk about what's the AX formula here? AX2. So I know that my shape is going to be linear. It's going to be, just adds up to 2. It's going to be sp hybridization. But is this one symmetrical or asymmetrical?
Asymmetrical.
Asymmetrical, because the bonding atoms aren't the same. So it's asymmetrical. Do we have phone call present? Yeah, we've got a nitrogen right here, right? So I have a polar bond. So I have a polar bond, it's asymmetrical, which means that this is going to be polar. You have to meet both criteria, not just one or the other. It's got to have a polar bond and be asymmetrical to be polar. And so if it's polar, what type of attractive forces does it have?
Dipole, dipole, and hydrogen.
No, well, this one doesn't have hydrogen bonds because the hydrogen's not attached directly to the nitrogen. Okay, so you're gonna have LDFs, because everything has LDFs. And it's gonna have the dipole-dipole. All right, this next one, really pay attention to this one. HClO3. We're running out of time, I'm gonna go fast. 1 plus 7 makes 8, plus 18, I get 26 electrons. What do we know when we have hydrogen and oxygen? What happens? Where does the hydrogen go?
Oxygen.
On the oxygen, not the central atom. This would work putting hydrogen on the chlorine. But when you have hydrogen and oxygen, remember I made the silly joke, hydrogens, oxygens, ho, they go together. Okay, HO. Always gonna be together. So you have chlorine, oxygen, 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 and just pick one to put the hydrogen on. See, because there is room here to put the hydrogen here, but that's not where it goes. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Remember, extra electrons go in the central atom. The peripheral will never have more than 8, but the central atom can, and the next one will show that. All right, so now we have 2 central atoms. So around the chlorine, what's my AX formula? AX, 1, 2, 3, and then we have 1 lone pair, right? So we say E. You go and you look on your sheet, you see that that's trigonal pyramidal. But 3 plus 1 equals 4. So 4 is going to be sp3 hybridization. Now, we're going to look at this one too. What's my AX formula around the oxygen?
AX2E2.
AX2E2. Okay? We're going to look and we're going to see that that's bent. And it's still sp3. 2 plus 2 equals 4. 3 plus 1 equals 4. Okay? Now, as a whole, is this a symmetrical or asymmetrical molecule? The whole thing is asymmetrical. Do we have foam column? Well, yeah, we got 3 oxygens and a chlorine, okay? So that means that it's going to be polar, which makes it, well, the whole thing is going to be polar. You have polar bonds and it's asymmetrical. So what type of attractive forces does it have? It's going to have all of them because now we have a hydrogen attached to the oxygen. So you have all 3, the LDFs, dipole-dipole, and hydrogen bonds. PCl5. Okay, so now I know I have 5 plus 35, I have 40 electrons. Just knowing that I have 5 like this tells me that I'm going to have an expanded octet. Now I'm going to go fast just so you can get these. You just put all 5 around the phosphorus. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 26, 28, 30, 32, 34, 36, 38, 40. Everything has 8. So it's AX5, trigonal bipyramidal. We don't have to worry about hybridization. It's symmetrical, therefore it's nonpolar. So what's the only type of attractive force? LDFs. Okay. Now NH3 is super simple. It looks like this. AX3E. Is this going to be polar or nonpolar?
Polar.
Polar. Is it going to have hydrogen bonds?
Yes.
Yes, because the hydrogen's attached directly to the nitrogen. So it's got hydrogen bonds and has all 3 attractive forces. Okay, all 3. And now lastly, though, I want to make sure I got time to this. BCl3. Notice where's boron located. Which family? B. Which family? Number 5. What family is it in? What's the number on top? 13. What's unique about all that if the central atom is in group 13?
They don't get 8, they only get
They
6.
don't need 8 electrons, they only need 6. It's an exception to the octet rule that you just have to know. Only group 13. So it's going to be boron, chlorine, chlorine, make sure we can see the same, chlorine, looking like this. It's AX3, so it's trigonal planar. It's symmetrical, so it's non-polar, only with LDFs. Okay? So you gotta just pay attention to that exception. Boron and aluminum are the 2 main types. Okay? Don't recognize hydrogen bonds. Okay? Good luck, study, email if you have any questions.